In this example, Jay is moving and he's going to hire the move out company to help him move. If he moves on a weekday, his friends are not going to be able to help him, so he's going to have to hire the movers for 6 hours of loading and unloading and 5 hours of packing and unpacking, and for a total of $720. But if he moves on the weekend, his friends will be around to help, so he'll only have to hire the movers for 4 hours of loading and unloading and 2 hours of packing and unpacking for a total of $400. So we know how much each of the hours is going to take, but we want to know how much the hours cost. How much is the move out company charging for the unloading and loading hours, and how much are they charging for the packing and the unpacking hours given the data that we have? So to do this, we're going to create two linear equations called a system of linear equations, and then we're going to use our Desmos graph to determine where those equations intersect each other so that we know the hourly rates for loading and unloading and the hourly rates for packing and unpacking. So first thing I did was I determined what I wanted X to be and what I wanted Y to be. So we're going to say that X is the cost or the hourly cost of loading or unloading the boxes, and then Y is the hourly cost of packing or unpacking the boxes. So in this equation, or for the first equation here, we know that 6 hours for loading and unloading. And since loading and unloading is the X, we're going to use a 6X here. And then we have 5 hours of packing and unpacking. So we're going to say that's 5, and packing and unpacking was Y, so 5Y. So 6 times whatever it cost for our unloading and loading hours, because there's 6 of those, and 5 unpacking and unpacking hours times however much those hours cost. And when we add those two amounts together, they should equal the $720 total that he would have to pay on the weekday. Then for the weekend move, he has 4 hours of loading and unloading, so 4 times whatever it costs to load and unload, and then 2 hours of packing and unpacking, so plus 2 times whatever it costs to pack and unpack boxes, and that would total up to $400 if he chose to do that on the weekend. We've opened a new Desmos screen, and now we need to type in our two equations. The nice thing about Desmos is we can type them in exactly how they are. We don't have to put them in y equals mx plus b form or anything like that. So I'm going to do 6x plus 5y equals 720 for my first equation. And then for my second equation, I'm going to do the 4x plus 2y equals the 400. I'm just going to go ahead and change this one to a different color so we can see it a little bit better. And now we have our two equations here, and notice I can't see them on the graph, so I'm going to want to zoom out a little bit till I can see them. And then I'm going to zoom back in a little bit more just so I can see where those two lines are crossing, because that's the area that we're looking at. Now here it is really important to remember that we said that our X was going to be our hourly cost for loading and unloading, and the Y is going to be the hourly cost for packing and unpacking. So all of those X values down there are all representing loading and unloading prices, and all of the Y values are representing packing and unpacking prices. And so now looking at these two equations, if I want to find the spot where they intersect on a Desmos graph, I just have to touch that point, and I can see that they're intersecting at the point 70, which is the X value, and 60, which is the Y value. So in the context of the problem here, that means that it's going to cost $70 per hour for a loading and unloading hour, and it's going to cost $60 per hour for a packing and unpacking hour.